Having all sorts of troubles today. We're live. Welcome to the MongoDB Podcast Live. My name is Michael Lynn. I'm a developer advocate at MongoDB. I'm struggling with technology this morning. I hope you're not. I hope you're well. And thank you so much for joining us today. We've got a fascinating live stream teed up for you today. We're going to be exploring the intersection of artificial intelligence and sound. And we've got a very special guest. We're going to bring him in shortly. In the meantime, as you pile into the room, everybody grab a seat, grab your favorite drink, it's coffee or tea, and get comfortable. Hey, it's Karen Walme. Bonjour. Thanks for tuning in. Where is everybody from? We've got somebody from London. We've got Mystic Monk. I'm not sure where you're from. And we've got Luce Carter watching the comments come in today. Speaking of comments, if you've got questions as we're going through the content today, you can put them right in the comments. Put your questions in the comments and we'll try to get to those. Hey, Mira from Sophia. Great to see everybody joining today. Thank you so much. And Luce is in Dublin. Fantastic. Get your questions ready too. This is a fascinating space. We're going to be diving deeply into artificial intelligence, MongoDB's vector search, how these things work together, and how you can explore these two spaces, artificial intelligence and sound. How can you search sound? I don't know. I'm really looking to learn a lot today from our special guest. Speaking of our special guest, he is a developer advocate at MongoDB. His name is Pavel Duchovny, and he works out of the Tel Aviv office. And he is really busy these days. He's writing a lot of content, doing a lot of live streams. He is a former senior technical services engineer, and now he's a senior developer advocate at MongoDB. And he's done a lot of stuff. We're going to explore some of the stuff that he's done right away. But let's bring Pavel on stage. Pavel, welcome to the show. It's great to have you on the podcast. How are you today?
Great to see you and see everybody's joining. I'm good. I'm great. How is everybody?
Well, I'm doing great. I'm here on the East Coast of the United States. You're in Tel Aviv, and we've got people coming in from all over the world. Chattanooga, Tennessee. Hey, Andrea. Merhaba. I'm not sure where that is. Dallas, Texas, Italy. Oh my goodness. They're coming in from everywhere. So, Pavel, you've been quite busy. You've been writing a lot of content, doing a lot of things at MongoDB.
Yes.
How long have you been at MongoDB?
I've reached my 8-year mark. So, 2016, I've joined MongoDB, was a technical services engineer for 5 years, which I guess is kind of the mark where you say to yourself, okay, I need to do something else. And I moved over to developer advocacy. To be honest, I've been doing developer advocacy when I was a technical services engineer. I've been in MongoDB world, in a few of them, written content, did like live talks, live streams already. So that was a natural move.
Yeah, fantastic. And today we're going to be exploring a really cool space. So you've been working with artificial intelligence, and as everybody already knows, at the heart of AI is a vector database, and that's MongoDB.
Yes.
You want to give folks a little introduction into Sync Scout, the project we're going to be looking at today?
Yes, definitely. So first of all, I don't know if there's anyone in the world already who didn't heard about AI and artificial intelligence. I guess a lot of people already heard about vector search and what does that mean, but we're going to dive deeper. I've literally met with one of my college buddies, and his name is Ran Shear, and he's running a big, not a big, but a solid production company. He's doing music for all sorts of venues, from TV shows to movies to awards around the globe. And he works closely and with producers who have those libraries of music where they need sometimes to find those audio tunes and those audio that you can put in the background of a commercial, of a movie, of a TV show. And very often what you want is something that sounds like something, but not exactly that. So you go to those libraries and you try to find whatever you are looking for. But how do you search music? Like, how do you search something for a puppy's commercial, right? The puppy's rolling in the toilet paper, or I don't know, an Atlantis city surrounded by, big bubbles, right? You need to know what are the tag words that those who produce the music put on their music in order to for it to bubble up. Vector search comes, like an AI in general comes and says, no, you can search context. You can tell me what you're looking for, and by the look of and feel of that, I can try and find what is best for you. So I can make recommendations based of my understanding of what you're looking for.
So now, I want to stop you because this is a really important piece to explain. So we're not talking about linearly searching through music and listening to it. We're talking about leveraging AI and having AI listen to the music and matching, I guess, like similarly sounding pieces of music. Is that correct?
Yes. Well, you can search on different dimensions. One of the dimensions is searching by an audio file, right? I have a song that I like. I need music that is similar to this, or can you find me something that I found, but I don't really know if I want this. I want something similar. So vector search allows us to do it, right? You can also search by just describing the scene, which also turns into the embeddings that today the LLMs produce. And then you can basically work in this multimodal environment where you can search by either audio, you can search by describing a scene, or you can actually uploading an image of a scene and searching for that.
But in order for you to search by scene, a description of a scene, there needs to be the paired description in the target, correct?
Well, the thing is, your context can be traversed into arrays, right? And those arrays represent that context. And the songs themselves, or the music itself, has also been going through the same process when it was put it in the database. So now you can compare whatever context you're looking for to the sounds that are already recorded in the database. And that's how the database and your application knows what's to fetch. You can definitely do a demo and show everybody what we're talking about.
I love it. I love it. And I definitely want to jump into the demo. There's a question. This is a great question. How can I use PDFs, podcasts, webcasts, and other documents for my chatbot? So I'm gonna pose it to you, but I have an answer as well.
Yeah, I mean, some of the things you're gonna see right now is not specifically related only to audio. It can be related to video. It depends on the module that you use that can transform the piece of media you're searching for to those embeddings, and then you can surface whatever context your application can provide to that specific thing. So whether it's a PDF, whether it's a podcast, which is usually either a video or an audio, you can transform them to this language, right? That the vector search can understand.
Yeah. And there's a great framework that has been put together by some folks that work at MongoDB. I'll put this in the comments. Actually, let me put it in a banner. I think that might be more helpful. There's a GitHub repository that provides some details about that. It's the MongoDB chatbot framework, and you can leverage that framework and the associated blog article to build a chatbot that can accept PDFs and other documents. Vectorize those, store those vectors in MongoDB, and using vector search, KNN, K nearest neighbor, return very similar pieces of information, right?
Yeah, you can upload PDFs and then do question answer on them, summarize them, right? There's a lot of things you can do when you ingest that into your database with our vector search capabilities. There's also an article from Han, I think I saw, that uses Mistral AI that also loads PDFs into a chatbot. So if you go on the Developer Center, there should be another article. There's a lot of content around this on our Developer Center.
Yeah, it's definitely a super popular topic amongst the articles on the MongoDB Developer Center. We'll get a link for you shortly on that. But let's get back to Sync Scout, and let's talk a little bit more about how you started the project, and maybe jump into a little bit of a demo.
Yes, definitely. All right, so we can first load the UI, and I'm sorry if I'm not that of a UI expert. I built this thing with Vue.js, right? So the main idea here, and hopefully you can hear the sound of those tracks. Let me try and let them.
You can hear it. Yep.
Yeah, so Ron Shear, who's working for Q's Assets, which is his company, they provide music to different vendors, and he was always frustrated with the fact that you have those labels on a music, but you cannot always know that a person will know how you tag your music. So he was reaching out to me and asking, like, I heard your work on AI and vector search, and I heard that can be useful with audio as well. And I was like, yeah, I heard that too, but I never tried it. So we started exploring it and investigating it and searching for materials about it. And this is how this project actually was born.
Okay, so we're looking at a basic search engine that's listing tracks of music, and then there's a search box.
Yes, there's a search box that you can describe your scene or request, choose the specific music genre that you might be interested in, and the specific usage type, like for example, a background or a theme or a feature, right? That you wanna use this music with. Let's say I want to do ambient, and I want to do Atlantis city relaxed, right? This is something that I want to search, right? So when I hit the search button, it actually goes and tries to understand what type of music is the most appropriate one in terms of like the musical genre and the industry, and it found this as the first option. I guess.
I feel like I'm in Atlantis.
Yes, and the nice thing is that those embeddings are embedded on top of the songs and the metadata, right? So we can take that embedding array, and we're going to see them in very shortly. We can take it and input it as an input for another vector query, and what that will do is I can do more like this, and then when I found something, I can actually turn it into a search term and search for things that might be related to, right?
Okay, so it does sound similar. So what you've done here is you've vectorized the tags, the labels associated with each piece of music.
Not only the labels, not only the labels, but also the BPM, the genre, the title. So the multi-module embedding on this one works on the textual embeddings, but you can still semantically search it. And you can use our filtering techniques within the vector search to add all of those bits and pieces of, like, I want to slice and dice it by other attributes, which is really cool.
Okay, so for the MongoDB experts, it feels like an aggregation pipeline, leveraging multiple stages. Maybe let's take a look at that. What does that look like?
You mean the specific text one?
Yeah.
Okay, so I'll need to reshare. I'll need to reshare the tab that has the article and the pieces of code that we can go through.
Okay, so while you're doing that, I'm going to place up a banner. If you want to read about this project, there's a link here, mdb.link/audio-search, audio-search. You can check out more information. This is the blog article that Pavel has written about this project.
So
so
it goes through all the stages of how we upload the MP3 files, how we actually implemented the uploading through AWS and get signed URLs. It uses app services to orchestrate a lot of the things that we require. It uses the AWS SDK to work with the S3 storage that we're using.
So you're storing the MP3s in S3?
Yes, the MP3s are stored in the S3. The links together with the embeddings and the metadata is stored in Atlas.
Gotcha.
Right, in MongoDB Atlas. Here, this is the heart of the system. So we're going to talk about it in a minute. It's the Python service that actually turns sound into embeddings, which is, I think, the most interesting one. But you were asking about the aggregation, right? The aggregation framework. So I'm using a 2048 dimension embedding protocol. It's
That's the size of the vector embedding.
Yeah, it's the size of the vector embedding. I'm using the dot product similarity search. This article still uses the previous syntax, but I'll need to refresh that to the new syntax. But basically, the dot product is the similarity. It's a similarity kind of function that we use in order to compare the vectors. So we have Euclidean, I think it's a Euclidean, Gaussian, and dot product. So Gaussian is very great for text, but dot product is great when you have text and dense data like sound. So dot product will be a good starting point because it does relate to both dense data and text data. So it's a good starting point where you try search indexes, and basically this is what I said. Like every file has this array of embeddings on them, right? They have this huge array that describes this specific MP3, and the vector search functionality, right, is basically running a vector search on the embeddings parsed, right? So I'm using OpenAI to embed my data, or I'm using this audio service to embed my data. I get the embeddings, and now I can do an aggregation pipeline and surface my 15 candidates, basically. And this is what I'm doing here. And then I can continue doing different things. Like I can search for either MP3 files, or maybe there's a WAV format, right? I can play. It's basically a coding environment where I can do a lot of transformation. Next thing is we can also union some other data sets. For example, if I have another metadata in my database that sits in a different place, I can continue kind of querying for other things and other pieces of data, right? As we move along, but this is basically the heart of the audio find, and I think it's a great opportunity now to try and show how we search by audio, which is I think the big announcement here.
Yeah.
So I'll share again the application tab. And we will move to the file-based search, which allows you to upload a file and search by it, right? So we'll go to downloads. I prepared some interesting sounds for us, like a big intro music, right? We're gonna run and upload it, and maybe it will fail like every good demo is, but this time it worked. So yeah, it's only 9 seconds that I found somewhere, right? Let's hear what it is. That's a big intro, no?
So now you've uploaded that, and you.
Right? It has similar drums. It has similar horns. This one, let's hear it. More dramatic, but maybe my catalog doesn't have like specifically this type of music, but it tried to find the most appropriate one for me.
So you've uploaded a file, you
Yes.
vectorize that file, and you're using that dot product to match.
Yes.
Yeah. And there's a great question from Karen. She says she never really understood num candidates. Is that basically a limit?
Again?
So she's asking, I never really understood num candidates. Is that the pool from which to pull the limit 15?
Yes. So that's a question I get a lot. And the num candidates, and maybe I'll stop sharing the screen again and move to the tab. Sorry for all the jiggle juggle. It's because of the audio function. Let's go back to the article itself, right? So num candidates, which is specified here, says how many documents am I going to pull from the space of the vector. It doesn't mean that those documents will be ordered correctly. What the engine does later on, it re-ranks them compared to my embedding. And then the limit will actually do like a MongoDB limit. So if I'm doing num candidates 100, right, and doing limit 15, I'll get only 15 answers, but 100 answers will be first fetched from the index space and then re-rank. And then re-rank to be reordered correctly.
Based on the specifics of your pipeline.
Yes.
Oh, so it's almost like another stage before limit.
Yes, because sometimes, there possibly neighbors that are in kind of like, I don't know if there's a possibility that there's similar distances, but they might be almost similar distances. And like, who do you put first? If you've done a num candidates 10 and one of them is placed 11 from the searching perspective, you might not even get it considered.
Okay, that makes sense. Another question from Dinesh. He's asking about pagination, and I think you would leverage limit to do pagination, right?
Yes, you will leverage limit. I guess that you can also leverage filter if you have if you kind of like sort by object ID, and you get the last object ID, and then you can do filter. Start from that object ID and up. There is also a pagination feature that came out in Atlas Search. I don't know how it works with vector search specifically, but I can look it up. Okay. There's a new feature for pagination within Atlas Search. I don't know if that works with vector search. I need to.
Yeah. Great. That's a great question, Dinesh. And if you want to jump into the MongoDB developer forums, we can specifically address that question and get some more information there. There's another question. What is the size of the MongoDB database you are querying against? How big is this?
I have around 3,500 wave, like audio pieces. So
and again, you're not, and you're not storing the MP3s in the database, right? You're not using blob storage. Yeah.
No.
Okay. Yep.
I'm using S3 store the data. Maybe we can go over a little bit over the script that does the audio embedding. That might be interesting.
Yeah.
So this is a service hosted on AWS. I used for simplicity, I used the Django web service. Really straightforward. It has an endpoint called download and embed, and it's a post method, right? It basically gets the file name and then downloads it from the S3 URL, right? And then, like when we search by audio, we first upload it somewhere, and then this thing can download it, store it as a temporary file, because I want, if something like crashes in the middle, I want to resume and don't want to download file again. And then I'm doing this get embedding for that specific file. And the get embedding is where the magic happens.
This
right?
is the call to OpenAI.
No, it's
No?
a module called Pan's Inference, and I have a link in this document, in this blog, to point to that specific module. It has a Hugging Face API, but you can also consume it directly from their repo. It's a locally based module, so you download it into your server and it sits there, right? And then you use Librosa to kind of load the file and normalizing it in a specific sample rate.
Mm-hmm.
And eventually you do the inference, which is the thing that creates the embedding. So what it does behind the scenes, and I didn't go too much in depth, but it turns the music into actual time series data. And then it runs the different its module on it and create a vector embedding out of it. Right. And then we finally kind of normalize it so that, the normalization phase like makes the numbers within the arrays standard between like different formats of audio files, basically.
Yeah.
And then we return it. And we return the normalized document, and we just say, here is the embedding, turn it into a list, send it back to the aggregation pipeline. Yeah. And if we go to the application again, sorry for all the jumping. If we go to the application again, and we open our developer console, I actually print the candidates and their embeddings, right? So I print the candidates that come back just for like a debug. And the last one is the image search, right? So we can take a nice image like this one, upload it, and then what we're doing in this case is we're not actually turning the image into an embedding, but I'm turning the image into a good context description and search via the text.
What model are you using to do that?
Yes, OpenAI Vision.
Okay.
So OpenAI Vision creates the text. You want to see the text?
Yeah, I'd love to see it.
Find music that describes a futuristic superhero soaring through a neon-lit cityscape at night.
Okay, so I'm guessing that some of that's hard-coded. So the front end of that, no? Well, how does it know to say find?
Oh, yeah. So the prompt engineering here is start everything with find.
Okay, yes. Yeah. So that's the hard-coded part.
Do we want to hear what it found?
Let's hear it.
That kind of like fits in, right?
It's pretty spot on.
Yeah, we can do more like this and try to find, like, let's say we say, okay, this one is a little more mellow, like it's trying to be ambient. Night snap. Yeah, I don't know. Maybe grab some of the sounds from the fantasy.
And genre.
Yeah, from the fantasy genre and added it. We can do one more file-based search if you want.
Sure.
Let's do something. So I don't know. I guess that people are familiar with. Guess I have like I think it's called. It's the the Terminator. I was big on that movie when I was younger. Yeah, I really like this sound. It stuck with me as like one of my favorite soundtracks in movies in general. That's why the first thing that I searched when I developed that it was this was this file. Yeah. Okay, let's hear it first. So hopefully that brings some nostalgic vibes.
Yeah,
to
definitely.
people. Yeah. Right? It is similar.
Very similar. That's pretty incredible. So is your friend in the music production industry, is he using this now?
Well, that's a prototype. We actually wanted to do maybe a more academic write-up of this thing, and definitely see. Well, it's not a secret that those capabilities are going into a lot of the libraries and a lot of the audio industry kind of main platforms, and it's not surprising. But I think what is surprising is that AI becomes more and more a commodity. So a single person like me can develop something like this with ease. You don't need to have this huge ML team anymore to build this stuff. You just need to have the right tools and Google.
Right. And access to the developer center.
Yes.
So there's a couple of questions. Let's just try and catch up. So Dinesh is asking about the repo. Is the repo referenced in the blog article?
Well, the repo itself of the full code is not referenced, but the bits and pieces of the code is referenced there. So the specific audio embedding module is placed as a small demo in a GitHub. The rest of the code is on the blog itself, like a lot of the code snippets, because I'm using app services. I've highlighted the main functions and the main endpoints that I'm using, and I think it's a good starting point for if you want to replicate that project.
Yeah. All right. So MD Bala is asking about the labels. The labels are added manually, right?
Yes.
So you started with a database of sounds, and the sounds had already been indexed with labels, right?
Yes. So somebody who's created the music labeled it. But if I label something lazy, and somebody will be looking for tired, right? In traditional databases, they won't
never find it. Yeah.
But in vector world, they will.
Because of KNN.
Yes.
Yeah. Okay. So the size of the database, I guess they're asking about the size of the S3 storage. That's going to be dependent upon how many MP3 files are in there. But what's the basic size of the S3 repository?
I mean, the MP3s here are 3 megabytes. So if you have 3,000, that would make it like 6 and something gigabytes.
Yeah.
Maybe a good thing to share maybe is my Compass that I'm connected to.
Oh, that's a good idea.
Yeah. So we can look a little bit on the data. Do you see the screen?
Nope.
Okay, so it says that my browser can't. Let me try and do that again. I can share my entire screen, right?
Yeah.
It's just that we're gonna see each other duplicated. Okay, let's share. Right. Can you see my screen now?
Yep, we can see Compass. Maybe do a Command plus. There you go. Okay.
That's good. Okay.
Yep.
So I've experimented with this project. So I ended up with different types of collections. But generally, you see those are the collections with the metadata they have the initial metadata that was loaded from that catalog, right? And those keywords were there, right? Like heist, mystery, action, comedy, right? But they are very sparse. Like, somebody said like it's mystery and action and comedy, right? But we need something to steal that. And this is where the vector search, encapsulating all of those together with the PPM, together with the genre, right? We can embed them all as an embedding input, and then we create those embeddings, right? And this is how those embeddings are looking.
Yeah.
Right. And the nice thing in MongoDB is you can have
multiple
embeddings, something that is not always present in vector databases. So I can have one field embedding one part of the document and another field embedding the other part of the document, and they live together, referencing to the same document.
Yeah. And you can version your embeddings.
Yes, you can. And you can actually say, you can tag each embedding with another field saying what is the module that did that embedding, like that embedding.
Yeah.
So the number of possibilities is actually enormous. And I'm thrilled to be building with this thing. And I think a lot of developers would be thrilled to see what they can.
Well, that brings us to Rajendra's question. What is the advantage of using MongoDB for this search?
Right. So the advantage of MongoDB is that it was easy to load the data. It is easy to represent it. It is easy to read it from the application side. I can do my Atlas search queries on it. I can do like various aggregation, pagination, but I can also do vector search. So I can do all of that on a single database.
Yeah.
Right. And tomorrow I'll have a new feature, right? I will want to aggregate how, like, I can record my search queries and see how my users are actually searching data and how they rate the searching capabilities, and I can act upon it. Right? It's not that easy if you don't have the operational layer that MongoDB offers within the database.
Yeah. And I think Armin is asking a very similar question. Wouldn't it be faster to store both data and embeddings in MongoDB? Absolutely. I mean, it comes down to physics, right? But maybe I don't know, Armin, maybe you can clarify, but are you asking if you wanted to store the MP3s in MongoDB? You could do that.
Yes, but I would be a bit hesitant about that.
Yeah. Yeah, especially since there may be MP3s that are quite large and would breach the 16 megabyte document size. Yeah.
Yes, and also, you need to remember that when you fetch a document that has an MP3 on it, you're actually going to download this entire data set.
Yeah.
Right. And within S3, they have like, and different blob storages, they have like really good optimizations for this kind of workload. So I will not run and store my MP3s in MongoDB. You can do it, but you need a very good justification to do that.
Yeah. A lot of overhead associated with that.
Yeah. This is the embeddings for sound. Look how they different.
Sparse,
They're very sparse, right? Because I guess those are really, really focusing on like sound specific embeddings. And text would have more characteristics to it, but sound has like very specific dimensions that they touch. Like, do sound touch color? I don't think so. Text do touch color, because if you've written something about a color, then one of this dimension might point to a color. Why they chose to do it so sparse? I guess that it's also because of the variety of sounds in the world. I really want to test this thing on something different than music. So think about testing it on car engines and their sound. So you can actually have car problems or engine issues be cataloged with their sound. And then if you come into the workshop, and they can just record the car and know what your problems are. Like, how cool is that?
That is amazing. I mean, there's so many, the possibilities are limitless. What about what about disease models and interactions? What if
Yeah,
you,
like the way I
what if you,
cough.
the
Yeah.
way you cough or the way you type?
Yes. So
Yeah.
I'll say sound have a big impact on our lives that we don't even understand.
Yeah.
And being able to vectorize it means a lot to a lot of industries.
Yeah. Here's a good question from Oleg. What is the maximum number of dimensions on a vector to store in MongoDB?
This one, the 2048. I was
48.
lucky. Yeah, if we have, yeah, the nice thing like OpenAI now allows you to shorten and control the number of embeddings. So you can actually say, I want to use this module that can support up to 3072 dimensions, but I want to shorten it. I'm willing to pay the little overhead of it being maybe less. Um, I don't want to use the word quality. It might be less detailed in a
Yeah.
way, but I need it for my specific use case. It works well enough, so I
Yeah.
can actually trim it down to store only 256 elements.
Mm-hmm.
We have to remember, the bigger the array, the more data MongoDB needs to scan, right? So if we can optimize the amount of the arrays that we store in the database and still get quality embedding searches, we probably want to do it.
Yeah. Yeah. Okay. Great question. If you have other questions, folks, now's the time. I want to remind folks to check below. There's a couple of links there. You can sign up for MongoDB Atlas for free, and you can try this yourself. You can follow along. There's a link to the blog article that Pavel wrote. What else is going on, Pavel?
Right. Yeah. So a lot of stuff. I've just released an article today.
I know you did. It's on Bedrock, right?
Yes, using AWS, Bedrock, and MongoDB for doing multi-module searches. So it actually talks about a chatbot that you can upload images and text and search a catalog of products. So, for example, I want to find like this bag, right? But I don't know how to describe it, so I can just upload the picture, and I can also add text. So I can upload a picture and say, I want this thing in blue, right?
Interesting.
So yeah, so the module support that. The demo that is there kind of like only receives text or images, but you can understand from the code how you can combine both. You just pass both from the UI to the backend, and it will work. And AWS Bedrock is a very nice suite of AI modules. Some of them generate images, some of them generate text, some of them generate embeddings. They have this multi-module embedding of images and text, which is pretty cool. Yeah, and some of them are proprietary for Amazon, some of them are hosted there and are third parties. But all of the embeddings that they produce are supported by MongoDB Atlas Vector Search. And I know we have a very neat baked-in integration that was announced lately with them, and it's coming out shortly. But we already can use the AWS client, either from app services or from your frameworks of use. They have support for Python, for Node, for Go. AWS has a very large SDK supporting a lot of languages. You can say that.
Yeah.
So.
Yeah. Well, quickly back to the Sync Scout, the sound project. How long did it take you to write that?
There was a lot of trial and error. I would say the foundation, a week.
Really?
A week to get everything running, and then it was only the bits and pieces of like, how do you host this service to not run locally, and that was like the things that required me another week, which are not related to to the database and to the embeddings and to the queries. It's more like this thing wants this SSL and this thing wants this SSL, and you need to to just integrate that. But on my laptop, it was running within a week.
Yeah, fantastic. Well, it's a great project and a really great example of how AI can be used, how vector search can be used in MongoDB. Is there anything else you want to share with the audience before we wrap up?
Yeah, I guess that it's one of those spaces that you just need to get your hands on, and then as soon as you get your first few lines of code in your first experience, you understand the numerous possibilities of it. And I think there's a lot of imagination that people can use vector databases, specifically MongoDB, but vector databases in general, to just develop new abilities that we haven't even dreamed of. So I think it's very exciting. It's very exciting as a developer and as a community leader here in Israel to be presenting this stuff. And hope to learn from a lot of other people who start to get their content and their projects in the air.
Yeah. Well, I'll encourage folks to jump into the community, share your thoughts. If you've got questions about this or any other MongoDB project that you're working on, this is the place to go. If you want to learn more about the Sync Scout, here's the link on the screen, mdb.link/audio-search. And of course, there are additional links below. You can check those out. You can sign up for Atlas for free. Pavel, it's been a great discussion. I want to thank you for taking the time to talk to me and for sharing your project.
Thank you. Thank you all for listening and joining, and hopefully, you can leverage that to your next project.
All right. Thanks, everybody. Have a great day.
Bye-bye.